Okay. Video 2 on reassessment 7, which is our work energy, our assessment on work energy. And what we have is we have a girl that is pulling a sled, and she's pulling there's a rope. It has an angle of 30 degrees, moving at a velocity of 3 kilometers per hour. And there's a person that's supposed to be sitting on this that weighs 26 kilograms. We also have a coefficient of friction of 0.16. What we're trying to find is the work done by the person in the book is Diane, but by the person. So the first thing I did was I totaled up the forces in the X and Y direction if we were to draw a free body diagram. We have is in the X direction we have the positive force of the tension cosine theta equals kinetic friction. I did this a little funny, but we can rewrite this equation as shown right here as the net of forces in the X direction as positive tension cosine theta, and we can replace the kinetic friction with the coefficient of kinetic friction times the normal force. Then I have all the forces acting in the Y direction, which is positive T tension sine theta minus mg plus the normal force. What I then did was I combined the two, and we have the coefficient of kinetic friction times the tension sine theta minus the coefficient mg plus the coefficient of the normal force. We then want to cancel out our ends as shown right here in this equation. I cancel it out, and we come up with T cosine theta plus the coefficient of kinetic friction, T sine theta equals the kinetic friction, mg. We then want, or minus mu k mg equals 0. We then want to solve for our tension, and we have mu k mg divided by the coefficient of kinetic friction sine theta plus cosine theta, and we get, once we plug in all of our numbers, we get that the tension of the string is 43 newtons. Now that we know the tension of the string, we can find the work that is done by the person pulling the sled. We know we're given, I didn't state this earlier, but we're given the displacement, which is 120 meters. So we're given that work equals the tension times cosine times our displacement. So work equals 43 newtons times cosine of 30, because the tension of the angle of the rope is 30, times 120, and we get that the person does 4,468 joules of work. You could just round that up and say that it's 4,500 joules of work. And like I said, this is the assessment for work energy, and this is my second video.